In example 2, we're given a table that provides data on family size and years of education for several individuals. And we want to repeat the process that we did in example 1, construct a model, identify and interpret the correlation coefficient, and then predict a future or unknown value by choosing a practical value for n. I've already input this data into Desmos. We can click on that magnifying glass icon to see our data plotted more appropriately, and then we can click that regression tool to create our linear model. So we have our linear model. We have our correlation coefficient of negative 0.969, which is close to -1. So we have a strong negative association in this case. And I'm going to retype my model using function notation. So that now I can quickly evaluate this model for different values of x that I might substitute in. So for instance, we could evaluate f of 4, which would give us 16.88891. So if we evaluate f of 4, we get approximately 16.8889. And to interpret that, we would say that we would expect a person with a family size of 4 to complete 17 years of education. This is, again, in this case, interpolation. Because 4 is larger than 3, so 4 is not included in our data set, but it is between the largest and smallest values that we have for family size. But now we want to talk about a couple of cases of extrapolation. So for instance, we're going to investigate f of 15 and f of 16 to see what happens with our model. So we're starting to talk about very large family sizes in this case. If we evaluate f of 15, we get approximately 1. If we evaluate f of 16, now we start getting negative values. So if we take it very literally, it would mean that someone from a family size of 16 attended negative school, which doesn't make sense. If we round it to the nearest whole number, that would be 0. This would imply that a person from a family size of 16 would never attend school. In the United States, that's illegal. You at least have to homeschool. Something has to happen. So what this suggests, since we keep getting closer to 0, is that this model fails us once we get into extrapolation that is too far removed from the values that we have in our data set. So extrapolation can start to fail, and the only way to know that is to do some further investigation. There are some further statistical procedures, or in this case, we can just try some practical results and see that those don't really make sense. So as we get into this idea of extrapolation, values that are far beyond the values for family size that we had in our original data set, the answers stop making sense. And what that suggests is that this linear pattern ceases to exist once we get into maybe very large families or something else. It suggests something, but that our results are unreliable. Extrapolation is not very good in this case.